Good day, fellow researchers and all ICI Tech 2021 participants. Allow us to introduce ourselves. My name is Trianggoro from the School of Information Technology, Universitas Putra, Surabaya, along with my colleagues Teresia, Rinabi, and Yosua. We are going to present our recent study with the title An Implementation of Support Vector Machine Classification for Developer Academy Acceptance Prediction Model. The background of our study is knowing that our Human Development Index data, as published by UNDP for 2020, Indonesia is currently 0.718. To see from a bigger picture, we are currently ranked number 107 out of 189 countries. Even though over the last 2 decades, Indonesia's Human Development Index has shown an increase from 0.513 to 0.718, or roughly 37.3%. But this figure still indicates that Indonesia is still far behind if Indonesia is to become the world 10th economic power in 2030, as mentioned by the President of Republic of Indonesia and confirmed by the Standard Chartered PLC long-term prediction. Hence, a long-term strategic plan must be formulated, particularly in the education sector. Education institutions in Indonesia in the past were generally pursuing idealism in excellent teaching, learning, and research, not closely involving industries in shaping their curriculum. However, this condition has changed since the announcement of Campus Merdeka program by the Indonesian Minister of Education and Culture. Developer Academy is an annual initiative from education institution and industry to provide training to final year students of the university with the skills they need when they graduate and work for the industry. The first year implementation in 2018 attracted around 600 students registered. And then the second year in 2019 attracted more students, with number reaching 1,000, which started to introduce fatigue to our staff who are doing the selection. Finally, last year, there were more than 1,200 students registering this program. The need for a better process and technology becomes essential to automate and predict the result. Selection methods for the participants are the stages started with general aptitude tests, continued with portfolio review, and the last one is the interview to confirm general aptitude tests and portfolio tests. These 3 scores were then become the features to predict whether an applicant will be accepted or not, along with few other features such as domain expertise, gender, and the age of the applicants.
Since the number of applicants are far greater than the admission officer, manually analyze those scores to evaluate the candidate will be costly, time-consuming, and also error-prone. With the help of machine learning algorithm, that problem can be addressed. Machine learning has the ability to learn from humongous amount of data and make prediction out of it. In this study, we assess some of supervised learning algorithms, including KNN, naive Bayes, SVM, decision tree, and random forest. We determine the best model for predicting the acceptance by performing parameter tuning to achieve better accuracy. The algorithm that we look deeper is SVM. It is a machine learning algorithm based on the concept of kernel. The SVM algorithm aims to separate the data by creating a maximum distance. In this figure, you can see that the distance is presented as a yellow surface. This distance or color is usually created by a hyperplane. The kernel function plays important role in creating this kind of hyperplane so that we can get a better way to separate the data based on its class. We are interested in this particular algorithm because SVM has mainly been used as a robust and powerful algorithm for solving practical binary classification problem. Dataset used in this study was the assessment data collected from the applicant. There are 527 valid applicant data. The dataset contains the applicant's GAT score, portfolio-based score, and interview score. The GAT score was obtained from the logic test and programming skills test. Meanwhile, the portfolio-based score obtained from the achievement or accomplishment of the applicant in projects or activities. And of course, achievement in the field of development will get a better score. Then, We have an interview-based score obtained from the competence of applicants in the interview process. We perform an explanatory data analysis to get better understanding on the data. One of interesting findings in this research is that the highest acceptance expertise is tech, IT, and IS, and followed by design. In our point of view, it can be caused by the advantage of having prior knowledge in programming that is evaluated during the selection process. Another interesting finding in this study is related to the participant category. If we briefly see the figure 5 in particular, we can make a statement that the academy accept more active students or fresh graduate compared to professional worker. However, if we look deeper, the acceptance rate for professional worker category is actually higher than the student or fresh graduate. We also did a further investigation on the gender-related issue. As we can see in figure 3 here, the number of registered applicants and accepted participants are equally proportioned. It can be understood that there is no bias to lean on specific gender in the evaluation process.
Moreover, we also take a deeper look to the observed score, like General Aptitude Test or GAT score, Portfolio score, and Interview score. The GAT can be used to test the applicant's thinking ability and their problem-solving capacity. Meanwhile, the participant's portfolio can be used to see their motivation and reflection of their achievements. In the end, the interview process can be used to measure the participants' knowledge and their social skills. We found out that some outliers in the data, but this number is not significant due to its small proportion. We also found the huge range of score among GAT, portfolio, and interview scores. In particular, the widest range happened in portfolio score. This result shows that there is a high variability in analyzed dataset. We developed our model using Python and scikit-learn library. We developed some classifiers models to compare the best classifier for our case. We use nearest neighbor, naive Bayes, support vector model and decision tree, and random forest classifiers. We evaluate our classifiers performance using accuracy and F1 score. The accuracy uses ratio of correct prediction and wrong prediction to overall data used. Meanwhile, F1 score is preferred than precision and recall scores because F1 score is a harmony value of precision and recalls themselves. The result shows that naive Bayes and support vector model have the best score, which is its 86%. Hence, the support vector model was selected because it has better performance in handling outliers than naive Bayes. Due to imbalanced data between accepted and rejected candidates, we implement two feature engineering. First one, we use synthetic minority oversampling technique known as SMOTH to resampling the accepted candidates, so the number of samples become balanced while also reducing the possibility of overfitting. The support vector model is an algorithm that have a hyperparameter. So the second feature engineering is tune the parameter by applying radial basis function to find the optimal hyperplane. And this is the support vector model is our best estimator model over all our research.
So the conclusion, preliminary finding from the study show that the support vector machine algorithm performs best with an accuracy of 86%. And this score was then increased by applying oversampling and kernel tricks to get an accuracy of 98%. Hence, it can be concluded that the prediction model has excellent performance. The future study, we might want to extend the deployment pace as suggested in CRISP-DM methodology, so that common users may easily use the prediction model through the web or mobile interface. We used 22 references for our research as follows. Thank you very much for your attention. See you again next time. Goodbye.